Hey kids, welcome to section 4.3, dividing polynomials. Today we're going to learn how to use polynomials or how to divide polynomials using long division and how to divide polynomials using synthetic division. So first let's talk about polynomials divided by monomials. Remember, a monomial is a multiplication of variables and numbers. So in letter A, I have 6x to the fourth y cubed plus 12x cubed y squared minus 18x squared y, all divided by 3xy. Well, whenever you have a polynomial in the numerator and a monomial in the denominator, you can take each of the terms and divide it by the monomial. So you can do 6x to the fourth y cubed and divide by 3xy plus 12x cubed y squared divided by 3xy minus 18x squared y divided by 3xy. And then you just need to simplify each of the terms. So 6 divided by 3 is 2. X to the 4 minus 1 or third power. Y to the 3 minus 1 or 2. Plus, we have 12 divided by 3 is 4. X to the 3 minus 1 is 2. Y to the 2 minus 1 or 1. Minus 18 divided by 3 is 6. X to the 2 minus 1 is 1. And a y to the 1 minus 1 is 0. So leave it the last term as negative 6x. Okay, let's try another one. This problem looks completely different from letter A, but it is the same type of problem. You have a polynomial divided by a monomial. So we're going to take each term in the polynomial and divide by the monomial. So 20c to the fourth d squared f divided by 4cdf minus 16cdf squared divided by 4cdf plus the last term 4cdf divided by 4cdf. Then we simplify each of these. So 20 divided by 4 is 5. C to the 4 minus 1 is 3. D to the 2 minus 1 is 1. And the f's cancel. Minus 16 over 4 is 4. C over C cancels. D over D cancels. And f to the 2 minus 1 or 1. Plus, and now 4 cancels with the 4. C's cancel, D's cancel, F's cancel. You have to be left with something. You are left with the number 1. So 5c cubed D minus 4f plus 1. Letter C, again, looks completely different from A and B. However, it is the exact same thing. You have a polynomial divided by a monomial. Remember that negative 1 power means that it can go in the bottom of the fraction and become positive. So you are essentially doing 18x squared y divided by 3xy plus 27x cubed y squared z over 3xy. So now we simplify 18 over 3 is 6. X to the 2 minus 1 is 1. The y's cancel. Plus 27 over 3 is 9. X to the 3 minus 1 is 2. Y to the 2 minus 1 is 1. And z. So 6x plus 9x squared yz. Okay, so what if the thing you're dividing by is not a monomial, but is instead a binomial or a trinomial or any other nomial? Well, we're going to do something called long division. Long division says that you can take a quantity and divide by another quantity. And you guys learned how to do this way back in like 4th grade. So we are going to take x squared plus 7x minus 30, and we are going to divide by x minus 3. So I know it looks weird because you've never divided with letters before, but it's the exact same process that you would use with numbers. So we are going to look at the problem and we are going to ask ourselves, how many times does x go into x squared? And the answer is x times. So I'm going to put the x above the other x. And then I'm going to multiply this x by x minus 3. So I'm going to do x times x is x squared. X times negative 3 is negative 3x. I'm going to draw my line and subtract. So x squared minus x squared is 0. 7x minus a negative 3x is 10x. And then I bring down my next term, minus 30. And then I repeat the process. I ask myself, how many times does x go into 10x? And the answer is 10 times. So I put it above the other number. And then I distribute. 10 times x is 10x. 10 times negative 3 is negative 30. Draw my line and subtract. 10x minus 10x is 0. Negative 30 minus a negative 30 is 0. If I get 0, that's a good sign. That means it divides evenly. So the answer is x plus 10. So you can check your work. If you multiply x minus 3 and x plus 10 and double distribute, you should get x squared plus 7x minus 30 back again. All right, let's try another one. This time we have x squared minus 13x plus 12, and we're dividing by x minus 1. So we're going to ask ourselves, how many times does x go into x squared? And the answer is x times. So I distribute. X times x is x squared. X times negative 1 is negative x. Draw your line and subtract. X squared minus x squared is 0. Negative 13x minus a negative x is negative 12x. Bring down the plus 12. Repeat the process. So how many times does x go into negative 12x? And the answer is negative 12 times. Distribute. Negative 12 times x is negative 12x. Negative 12 times negative 12 is plus 12. Draw your line and subtract. Negative 12x minus negative 12x is 0. 12 minus 12 is 0. That means it goes in evenly. The answer is x minus 12. All right, let's get a little more exciting. So notice this time in letter A, we have a polynomial divided by a binomial, but notice that the order of the binomial is kind of mixed up. I strongly encourage you to rearrange it and say negative a plus 2. It will be a lot easier to divide if you have the values of the polynomial in descending order. So I'm going to write my a cubed plus 2a squared plus 4a minus 9. And I'm going to divide by negative a plus 2. So I'm going to see how many times negative a goes into a cubed, and that's negative a squared times. So then I distribute. Negative a squared times negative a is a cubed. Negative a squared times 2 is negative 2a squared. Draw your line and subtract. A cubed minus a cubed is 0. 2a squared minus a negative 2a squared is 4a squared. Bring down the plus 4a. Repeat. Negative a goes into 4a squared how many times? The answer is negative 4a. Distribute. Negative 4a times negative a is 4a squared. Negative 4a times 2 is negative 8a. Draw your line and subtract. 4a squared minus 4a squared is 0. 4a minus a negative 8a is 12a. Bring down the negative 9. Ask yourself how many times negative a goes into 12a. The answer is negative 12 times. Negative 12a times negative a is 12a. Negative 12 times 2 is negative 24. Draw your line and subtract. 12a minus 12a is 0. Negative 9 minus a negative 24 is 15. So we have our first remainder. To write your answer to the long division problem, you're going to write what you had up top. Negative a squared minus 4a minus 12. Then since this 15 is positive, you're going to put plus, and you're going to put the 15 over whatever it was that you were dividing by. In this case, 2 minus a. If we had a negative 15 left over, then we would put a minus 15 over 2 minus a. Okay, letter B. Notice that this problem has a binomial that we are taking to a negative power. Remember, that means I can put that binomial in the denominator, so we're essentially doing division. So I'm going to write r cubed plus 6r squared minus r minus 4. And we're going to divide by r squared minus 1. So we're going to ask ourselves, how many times does r squared go into r cubed? And the answer is r times. Then I multiply. R times r squared is r cubed. R times negative 1 is negative r. Look how I have to line up my values when I long divide. All the powers have to be below each other. So we draw our line and subtract. R cubed minus r cubed is 0. Notice I have just a 6r squared that I can bring down. Then I have negative r minus a negative r, that's 0. And then I bring down my last term, negative 4. Now I repeat, r squared goes into 6r squared how many times? The answer is 6, so plus 6. Then we distribute. 6 times r squared is 6r squared. And 6 times negative 1 is negative 6. Draw your line and subtract. 6r squared minus 6r squared is 0. Negative 4 minus a minus 6, that's negative 4 plus 6, that's 2. So we have a remainder of 2. So we have r plus 6 plus 2 over r squared minus 1. So sometimes you get pretty numbers, sometimes you don't. Sometimes you get remainders, sometimes you don't. All right, here are 2 more. This time I'm not necessarily dividing by a binomial. Notice that in letter A, I am dividing by a trinomial because it has 3 terms. The process is exactly the same. So we're going to take x cubed minus 2x squared minus 9x plus 18. And we're going to divide by x squared minus 5x plus 6. So you're going to take the first thing on the outside, x squared, and see how many times it goes into x cubed. The answer is x times. Notice I lined it up above my other x's. Then I distribute. X times x squared is x cubed. X times negative 5x is negative 5x squared. X times 6x is 6x. Draw your line and subtract. X cubed minus x cubed is 0. Negative 2x squared minus a minus 5x squared is 3x squared. Negative 9x minus 6x is negative 15x. Bring down the plus 18. Now see how many times x squared goes into 3x squared. The answer is 3 times. Distribute. 3 times x squared is 3x squared. 3 times negative 5x is negative 15x. 3 times 6 is 18. Draw your line and subtract. 3x squared minus 3x squared is 0. Negative 15x minus a negative 15x is 0. And 18 minus 18 is 0. No remainder. X plus 3 is your answer. All right, finally, letter D. Notice in letter D that the powers are to the fourth, to the second, to the first, and 0. We'll take a look at the previous problem, 3, 2, 1, 0. 4, 2, 1, 0. We're missing an x cubed. I need to use placeholders with 0 if I ever need a power, because all powers must be represented from the highest down. So when I do my long division, I have x to the fourth plus 0x cubed plus x squared minus 3x plus 5. And I'm dividing by x squared plus 2. So take a look at the first things. X squared goes into x to the fourth how many times? The answer is x squared. Then I distribute. X squared times x squared is x to the fourth. X squared times 2 is 2x squared. Make sure you line up your powers. Draw your line and subtract. X squared minus x squared is 0. I can bring down the 0x squared, but it's nothing. X squared minus 2x squared is negative x squared. Bring down the minus 3x. X squared goes into negative x squared how many times? The answer is negative 1. Line it up. Negative 1 times x squared is negative x squared. Negative 1 times 2 is negative 2. Draw your line and subtract. Notice I'm at the end here, so I also should bring down that plus 5. So negative x squared minus a minus x squared is 0. The negative 3x comes down. And we have 5 minus a negative 2, which is 7. So this time we have x squared minus 1 plus, and then negative 3x plus 7 on the top, and x squared plus 2 on the bottom. All right, so that's long division. It's useful when you're trying to divide a polynomial by another polynomial. Sometimes, though, it's easier to do something called synthetic division. Now, synthetic division is a simpler process when you divide polynomials by binomials. The only problem is that synthetic division works best when you have a linear term without a coefficient bigger than 1. So x plus 2 or x minus 2. But once you put that number in front, like 2x plus 2, it gets a little trickier. So to do synthetic division, you're going to write the coefficients of the dividends so that the degree of the terms are in descending order. We wrote that. Write the constant r of the divisor x minus r in the box. Bring the first coefficient down. Multiply, add, repeat. This is your recipe box you can look at later. Let's learn how we do synthetic division. So use synthetic division to find each quotient. I can do these exact same problems, kids, using long division, but it's typically easier if the number that you are dividing by is a linear term with a coefficient of 1. If it's not, then it gets a little tricky. So what we're going to do is grab the coefficients, the 2, the 3, the negative 4, and the 15. Make sure you also use placeholders if you need to. Then you're going to draw this little L-shaped line. And then we're going to put a number out here in front of the 2. The number that I put out in front of the 2 is what you get when you set the term you're dividing by equal to 0. So I would minus 3 to both sides, and I get x equals negative 3. Negative 3 is the root, and x plus 3 is the factor. I'm going to put the root on the outside. Then synthetic division says you bring down the 2 and you leave it. And then you multiply 2 times negative 3 and you get negative 6. And then you add these and you get negative 3. And then you multiply. Negative 3 times negative 3 is 9. And then you add these and you get 5. And 5 times negative 3 is negative 15. And you add them and you get 0. Getting 0 is a good thing. That means that this first polynomial is divisible evenly by the second polynomial. I can also write what's left after I divide. This number 2 goes with x to 1 less power than the first number that I started with. So I started with x to the third. So my answer starts with x to the second. And then my powers go down from there. Write the negative 3, go x to the first. Write the power of 5, or write the 5, and do x to the power of 0. So this is really 2x squared minus 3x plus 5. So if I were in fact to multiply 2x squared minus 3x plus 5, multiply that by x plus 3, I would get this original polynomial back again. All right, let's do another one. This time I'm going to grab the coefficients 3, negative 8, 11, and negative 14. I'm going to set x minus 2 equal to 0 and get a positive 2. That 2 is going to go on the outside. And now I do synthetic division. Bring down the 3. Multiply 3 times 2 and get 6. Add to get negative 2. Multiply negative 2 times 2 to get negative 4. Add to get 7. Multiply 7 by 2 to get 14. Add to get 0. So my answer is 3x squared. Because I started with x to the third, I finished with x to the second, minus 2x plus 7. Okay, so they're not always going to come out with remainders of 0. Sometimes you're going to get non-zero remainders, and that's okay. Also, be on the lookout for powers that do not exist in the original problem. Those must be accounted for by using a 0. So for instance, I'm missing 0a cubed. So when I grab my coefficients, I'm going to put a 4, a 0, a 2, a negative 4, and a 12. When I put my number out in front, I'm going to set this a plus 2 equal to 0. So my a value is negative 2. That's my root. So I'm going to put a negative 2 in front. I'm going to bring down the 4, and I'm going to multiply by negative 2 to get negative 8. And then I'm going to add to get negative 8. Then I'm going to multiply negative 8 and negative 2 to get 16. And I'm going to add the 2 and the 16 to get 18. And then I'm going to multiply 18 times negative 2 to get negative 36. And then I'm going to add to get negative 40. And then I'm going to multiply negative 40 times negative 2 to get 80. And I'm going to add them to get 92. 92 kids is my remainder. Now my original problem started with a to the fourth. So my answer is going to start with a cubed. So 4a cubed minus 8a squared plus 18a minus 40 plus 92 over, and the quantity that you put in the denominator of the fraction is what you were dividing by initially, which is a plus 2. And there's your answer. Okay, letter D. It looks like if I set this equal to 0, b minus 2 equal to 0, I get b equals 2. It looks like I'm also missing a b squared term, so I need to make sure I keep a 0 there. So when I grab my coefficients 6, negative 8, 0, 12, and negative 14, I'm going to synthetically divide with a 2 on the outside. So let's bring down the 6. Multiply 6 times 2 to get 12. Add to get 4. Multiply 4 times 2 to get 8. Add to get 8. Multiply 8 times 2 to get 16. add to get 28. 28 times 2 is 56. Negative 14 plus 56 is 42. That's my remainder. My original problem started with b to the fourth, so my answer is going to start with b to the third. So 6b cubed plus 4b squared plus 8b plus 28 plus 42 over b minus 2. Okay, well, what happens when the coefficient in front of the linear term, the leading coefficient, is not a 1? Well, before I can do anything, I need to make it a 1. So here, if I want to get rid of the 2, I can divide everything by 2. And if I divide one thing by 2, I need to divide everything by 2. So this means I get 4x to the fourth minus 2x squared plus 1/2 x plus 2 divided by x plus 1/2. So I can synthetically divide. It looks like I'm missing a x cubed term. So I'm going to do 4, 0, negative 2, 1/2, and 2. When I synthetically divide, remember I'm going to pretend this is equal to 0, so I'm going to get negative 1/2. That means I'm probably going to have fractions, but that's okay because you've got a calculator. So let's bring down the 4 and let's multiply. 4 times negative 1/2 is negative 2. Let's add to get negative 2. Multiply negative 2 times a negative 1/2 is a positive 1. We can add to get negative 1. We multiply negative 1 times negative 1/2 to get a positive 1/2. We add to get 1. We multiply 1 times negative 1/2 to get negative 1/2. And 2 minus 1/2 is 3/2. My original problem started with x to the fourth. So my answer is going to start with x cubed. So 4x cubed minus 2x squared minus x plus 1 plus 3/2 over x plus 1/2. Now, you're never allowed to leave a fraction within a fraction. So we're going to leave the first part the same, 4x cubed minus 2x squared minus x plus 1. But now in order to get rid of the fractions, I want to multiply the top and the bottom by 2. That will get rid of any fractions that I have. So 3/2 times 2 is 3. X times 2 is 2x. 1/2 times 2 is 1. So it's that original denominator back again. Now the top number may change, but usually it doesn't. All right, let's look at letter B. Well, we've got a 4 in front here, so that means we need to divide everything by 4. So that leaves me with 2y to the fifth minus 1/2 y to the fourth plus 4y squared plus 1. And we're dividing that by y minus 1/4. Now it looks like I'm missing y cubed and y to the first. So we need to be careful when we're doing our synthetic division. So I got a 2, a negative 1/2, a 0, a 4, a 0, and a 1. And when I do my synthetic division, if I set this equal to 0, I'm using 1/4 as my number on the outside. So bring down the 2. 2 times 1/4 is a half. Negative 1/2 plus 1/2 is 0. 0 times 1/4 is 0. Add and you get 0. 0 times a fourth is 0. Add it and you get 4. 4 times a fourth is 1. Add it and you get 1. multiply it by 1/4. Oh, wait, hold on. This should be a -4 right here. Sorry. -4. So this is a -4. So this is a -4. So when I multiply, I get a -1. Yep, so that's a -1. When I multiply -1 times 1/4, I get -1/4. Add them and you get 3/4. So notice I've got some missing space. My highest exponent when I started was a 5. That means mine's going to be a 4. So 2y to the 4th. I have a 0y cubed, a 0y squared. So I have a -4y, a -1, and then plus 3/4 over y minus a fourth. However, I can't leave fractions in a fraction, so I'm going to multiply the top and the bottom by 4. Let's make that look a little better. So I'm going to leave 2y to the 4th minus 4y plus 1. I'm going to multiply the 3/4 times 4 to get 3, 4 times y to get 4y, and 1/4 times 4 to get 1. So 2y/4 minus 4y plus 1 plus 3 over 4y minus 1. Fractions can be ugly, kids, but your calculator can do it for you. All right, we have 2 more examples. Watch for your missing exponents and be careful with the fractions. So I need to get rid of the 5 in front, so we're going to divide everything by 5. That's going to give me 3b cubed plus 8/5 b squared minus 21/5 b plus 6/5. And we're dividing everything by b minus 4/5. So I'm going to grab the 3. Doesn't look like I'm missing any exponents. The 8/5, the minus 21/5, and the 6/5. And I'm setting this equal to 0, so I'm getting a positive 4/5. So I'm going to bring down the 3, and I'm going to multiply 3 times 4/5, that's 12/5. I'm going to add 8/5 and 12/5 is 20/5. 20/5 is 4. Then I'm going to multiply 4 times 4/5 is 16/5. I'm going to add -21/5 and 16/5 to get -5/5, which is -1. Then I'm going to multiply -1 times 4/5 to get -4/5. Then I'm going to add 6/5 and -4/5 to get 2/5. My original problem started with a third power, so I'm going to start with a second power. So 3b squared plus 4b minus 1 plus 2/5 over b minus 4/5. Well, I can clean that up and say 3b squared plus 4b minus 1. I'm going to multiply top and bottom by 5. So that gives me 2 on top and 5b minus 4 on the bottom. All right, kids, last question. Looks like I need to divide everything by 3. So 2c cubed minus 17/3 c squared plus 2c plus 8/3, all divided by c minus 4/3. So if I set this equal to 0, I'm using positive 4/3. I don't think there's any missing exponents, so 2, -17/3, 2, and 8/3. I'm using a positive 4/3 on the outside. So I'm going to bring down the 2, multiply 2 and 4/3 to get 8/3. Add these together, -17/3 plus 8/3 is -9/3, which is -3. Multiply -3 times 4/3, that's -4. Add these together, 2 and -4, you get -2. Multiply -2 times 4/3 is -8/3. Add 8/3 and -8/3, you get 0. Oh, look at that. No remainder. My problem started with a cube, so my answer is going to start with a square. 2c squared minus 3c minus 2. And there you go. All right, that's the end of section 4.3. If you have any questions, please let me know. And as always, keep calm and keep trucking.